How did Rome build something this massive, this fast, and this precise 2,000 years ago? First, we must understand why it had to exist. And to understand how it was built, we must understand why. In architecture, context is everything. In 68 AD, Emperor Nero committed suicide, plunging Rome into chaos. Nero was hated by the Senate and much of the populace for his extravagance. After the Great Fire of Rome in 64 AD, Nero had seized a massive swath of downtown Rome to build his personal pleasure palace, the Domus Aurea, Golden House. In the center of this complex, he dug an enormous artificial lake. Out of the ensuing civil war emerged Vespasian, a pragmatic general and founder of the Flavian dynasty. Unlike Nero, Vespasian had no divine lineage or royal claim. He needed legitimacy, and fast. His solution was one of the most brilliant acts of political propaganda in history. Vespasian ordered large portions of Nero's palace demolished and, most importantly, drained Nero's private lake. On that exact site, he commissioned the largest public entertainment structure the ancient world had ever seen. This was not just construction, it was political erasure. Vespasian was literally giving the heart of Rome back to the people. The structure was originally named the Flavian Amphitheatre after Vespasian's dynasty. It later became known as the Colosseum, not because of its size, but because of a nearby 100-foot-tall bronze statue of Nero, the Colossus, which Vespasian had altered to resemble the sun god's soul. Even before a single stone was laid, Roman surveyors and architects had to define an almost impossible geometry. The Colosseum was designed as a perfect ellipse, measuring 189 meters long and 156 meters wide. Its outer walls rose nearly 50 meters high, roughly the height of a modern 15-story building. It could realistically hold between 50,000 spectators to 60,000 spectators, providing a perfect theater atmosphere. The crowd packed tightly into stone seating. Crucially, the Colosseum was not designed as one single structure. It was engineered as 80 wedge-shaped segments and repeated around the ellipse. This modular design allowed incredible speed and precision. It also provided long-term repairability. Damage to one section would not compromise the entire structure. Even the Romans did not know that one day in the future, this would be a wonder beyond imagination for generations to come. The entire construction took roughly 8 to 10 years, begun around 72 AD under Vespasian, completed and dedicated in 80 AD by Titus. The greatest challenge was the very first step. They had to build on top of Nero's artificial lake. The site was a swampy depression. The engineers dug a massive elliptical ring trench encircling the future arena. A very complex network of subterranean drains channeled water away toward the Tiber River. Once the lake was drained, they poured a colossal concrete ring, about 12 meters deep and 50 meters wide. This buried donut stabilized the amphitheater on the soft valley floor. This donut of concrete is also the unsung hero of the Colosseum, stabilizing the structure on the soft valley floor. After curing, the superstructure rose. No mortar held the main travertine blocks or the precision cutting. Roughly 300 tons of iron clamps locked the stones, resisting earthquakes. 80 massive radial walls fanned out from the arena's center. These walls acted like the spokes of a wheel, supporting the rising tiers of seats. The Roman architectural revolution was predicated on the arch. The arch allows you to span large spaces while supporting immense weight. The outer facade consists of 3 stacked levels of 80 arches each. Crucially, the corridors inside the Colosseum that run beneath the seats are barrel vaults made of concrete. These concrete vaults are what physically held up the tens of thousands of screaming spectators. The Roman engineers have calculated everything in a precise order to achieve the perfect results. In fact, the genius of the Colosseum lies in the strategic use of materials based on their weight and strength. It gets lighter as it goes up and it gets stronger as it goes down. Over 100,000 cubic meters of massive travertine blocks were quarried from Tivoli 20 miles away. This heavy, durable stone was used for the main load-bearing pillars and the ground floor. A softer, lighter volcanic rock used for secondary walls, a mixture of volcanic ash, pozzolana, lime, and rubble. It could set underwater and was immensely strong. Brick-faced concrete used heavily in the upper levels to reduce load. It was used for the foundations and the vaulted ceilings that supported the seating tiers. Brick-faced concrete used heavily in the upper levels to reduce load. A softer, lighter volcanic rock. For secondary walls and infill. The Roman architectural revolution was predicated on the arch. The arch allows you to span large spaces while supporting immense weight. The outer facade consists of 3 stacked levels of 80 arches each. Crucially, the corridors inside the Colosseum that run beneath the seats are barrel vaults made of concrete. These concrete vaults are what physically held up the tens of thousands of screaming spectators. The Romans were masters of crowd control. The Colosseum was designed so that 50,000 people could enter or exit in roughly 20 minutes. They achieved this through 80 ground-level entrances. 76 were for the general public, numbered I to LXY, still visible today. These entrances led to staircases and corridors called vomitoria, from the word to spew forth. These passageways spewed people rapidly into their assigned seating sections, cavea, which were strictly segregated by social class. The attic and the roof, the Velarium, the fourth and highest level, the attic, was built lighter using mostly brick and tuff rather than heavy travertine. Along its rim, stone sockets and timber masts. The Colosseum had no permanent roof, but it had the Velarium. This was a massive, retractable canvas awning used to shield spectators from the Roman sun. It was operated by a special detachment of Roman sailors from the Messinum naval fleet, using a complex system of ropes and pulleys rigged to 240 wooden masts around the top of the stadium. Originally, the arena floor was wooden and covered in sand, and it was supported by wooden pilings. Ancient sources suggest that in the earliest years, the arena may even have been flooded for mock naval battles called Naumachia. But Domitian wanted absolute control over the spectacle. He excavated beneath the arena and constructed the Hypogeum, a 2-level underground labyrinth of tunnels, cages, and armories. The Hypogeum was a hidden machine beneath the arena. At least 24 to 28 human-powered elevators worked below. Ropes, pulleys, and capstans hauled platforms straight up from the darkness. Cages with lions, bears, and gladiators shot through trapdoors in the floor. Hinged platform scenery. The fighters appears instantly on cue. Once the Hypogeum was installed, flooding the arena was no longer possible, but the spectacle became far more theatrical, controlled, and precise. The Colosseum was completed in under a decade, an astonishing feat. This required enormous logistics, dedicated roads from Tivoli, hundreds of ox-drawn carts moving daily, and a massive labor force. Much of the brutal labor was performed by tens of thousands of slaves. Yet despite earthquakes, fires, and centuries of damage, the Colosseum still stands. Its modular design allowed repairs without collapse. Its acoustics amplified the roar of the crowd. Its numbered entrances functioned like a proto-ticketing system carved in stone. It was not just a monument, it was a living machine. The Colosseum was built to function, politically, socially, and mechanically. Built to erase a tyrant, the Colosseum ended up preserving a civilization. Empires fell, emperors vanished, but the engineering remained. Thank you for watching. Subscribe for more stories that reveal how the world was really built.